Recording in progress. Hello，现在北京时间7点了，各位选手、各位专家，大家上午好、下午好、晚上好，很高兴今天大家又见面了。今天是我们跨时区的第4天训练营，也是我们训练营技术讲解的最后一天。今天呢，还是老规矩，邀请各位有摄像头、有麦克风的都开一下摄像头，然后或者打开麦克风，大家打个招呼，记录一下咱们跨国训练营的一个美好时光。今天第4天了，大家就不要那么害羞了，毕竟之后咱们比赛的时候还要赛场见，提前见个面也好呀。然后正好呢，咱们也花几分钟等一下其他还没有上线的一些选手专家们。现在是自由活动时间，咱们可以相互的聊聊天，都可以的。现在的话呢，我先讲一下咱们今天训练营的一个主要的内容。今天的主要内容的话呢，是由周老师进行一个主讲，分享的内容是关于神经网络，从基础的卷积、实化、全连接开始介绍，再到后续的计算机视觉方向常用模型进行一些介绍。然后明天的话呢，我们就会介绍咱们竞赛使用的一个平台，一个大致的介绍，让各位选手对平台有一个简单的了解。然后也会拿咱们公布的一个样题进行一个简单的分析。
We will analyze the sample questions of the competition.
所以今天是咱们训练营知识点的最后一天了。
Today will be the last day for the technical exchange of this training camp.
那么下面的时间就交给周老师。来，周老师，请您共享屏幕，开始我们今天的训练营内容。周老师，您没开麦，还听不见你讲话。
好的。好，各位选手。Good evening, ladies and gentlemen. Today, I will be the one to share some of the AI technical to all of you. First of all, I would like to give you a brief self-introduction. My name is Zhou Yaxiong, and I have graduated for about 10 years, and I mainly engage in Python and AI construction. Today, I will lecture and share the techniques around the AI. On the first page, let's have a browse of the content for today's training. In today, totally, there will be 4 parts included. The first one is convolutional neural network basis. The second one is the model evaluation matrix. The third part will be the TensorFlow basics. And the last one will be the classic models of visual direction and orientation. Now let's go to the first part. That is the basics of convolutional neural networks. I would like to show you this picture at the very beginning. As you can see, this picture shows you the brain. In this picture, all of these dots that lighted are the neurons in our brain. Here, we can also call it the biologic neurons. In artificial intelligence, there's one of the concepts that is the artificial neurons. So compared to the artificial neurons and the neurons in our brain, what are the differences and what are the similarities? Now let's look at this. So from this image, we can see that in our brain, there are various and thousands of the neurons. So it formulate a network. In the artificial neurons, it is also the same that we have the artificial neurons that connect to a network. And the neural network is a kind of machine learning technology, and it simulates human brain of its neural network. And the purpose is to expect and realize the artificial intelligence that is similar to the human activities. For example, to predict and to determine, etc., and etc. So this technology in artificial intelligence is called the neural network. Also, we can add two words we can add one word that is artificial. That is to segment with the biological neurons. In the computer terminology, when we say neural network, that refers to the artificial neural network. For the human brain, the neural network is a very complex organization. For example, an adult, there are estimated 100 billion neurons in our brain. That's a big number. Well, in artificial intelligence, how can we simulate the human neural network? Let's look at these two pictures. The pictures are showing the neurons that formulated a neural network chart. So let's look at all of these circles. These circles represent each of the artificial neuron. According to these neurons, it formulates a net, and we can call it the neural network. So there are many layers in these neural networks. The left one is called the input layer, and the one in the middle is called the hidden layer. Well, for the hidden layers, it might be a lot rather than just one layer. But in here, the picture only shows you that one hidden layer. That is to say, in the real neural network, the hidden layers might be multiple. And the layer on the right side is called the output layer. And the chart on the right is similar to the first one on the left. It is just the differences of the orientation. Also, it has the input layer, hidden layer, and output layer. Now let's look at the next knowledge. That is the neural model. Well, a neural model includes the functions of inputting, outputting, and computing. Let's look at this picture. It is a classic neural model. It says some of the participants and experts, when you have done the research about the biology, you can combine the biological neuron network to get to understand the artificial neuron network compared to the artificial neural networks and the biological neural networks. First of all, we can imagine the input is the analogy of the dendrite, and output is the analogy of the neurite or axon, and computing is the analogy of the cell nucleus. Here, for saving time, I will not further introduce the biological neural networks. If you're interested, after the class, you can do some research about the differences and similarities between it. Now, let's look at this picture. Well, there are the input. We can see from picture that there are 3 channels of input and 1 channel of output, and 2 functions of calculation. First of all, input. After inputting, there's one of the weight, and the input will multiply to the weight and operate the algorithm. There are 2 calculations including. At the center of this picture, the arrow lines, we can call it the connections. Each of these connections has a weight, and it is passed through the weighting pass, and this is the neural model. And this is for you to remember and understand the neural model. And next knowledge is called the neural network that constructed by all the neurons. The first one that we use is the deep neural network and the full connected neural network. For the computer vision, we do the image static morphological feature extraction. We use the residential network, and the future will be introduced the convolutional neural network, which is called CNN in abbreviation. So the natural language processing and text timing and syntactic feature extraction, and also the recurrent neural network. Next, we'll focus on the CNN, that is the convolutional neural network. Now, let's look at the picture. This is a convolutional neural network structure. Let's see how many layers there in the CNN. The left one is the input layer, and then it goes to the convolutional computing layer and the pooling layer. In the convolutional computing layer, there are several layers, as we can see from the picture. The conv layer 1 and conv layer 2, and also as same as the pooling layer. Except pooling layer, there are incentive layer and fully connected layer, which is called the FC layer. And this picture shows you the structure, the basic structure of convolutional neural network. Now I will introduce each layer of the CNN structure. The first one, input layer, It is mainly to pre-process the original image data, which is called the original image data preprocessing. It includes the meaning, that is to center all dimensions of the input data to 0. And its purpose is to pull the center of the sample back to the origin of the coordinate system. The next one, normalization. That is to normalize the amplitude to the same range. That is to reduce the interference caused by the differences in the value range of the data in each dimensions. For example, if we have two features, A and B, in two different dimensions, and A ranges from 0 to 10, while 2 ranges from 0 to 10,000. If we directly use these two features, it will be problematic because of the different ranges. Then the best practice is to operate normalization. That is to change the data of both A and B to change to the range of 0 to 1. Also, let's say if the data has the different weight of the amount, on this situation, we cannot compare them directly. On this situation, we can also use the method of normalization so that we change the unit and we make the unit not to interfere the analysis of the data. The next one is the PCA, that is called the principal component analysis and whitening. That is to whiten normalize the amplitude on each feature axis of the data. And those are for the input layer. Now, let's go to the convolutional computing layer, which is the very important layer in CNN. The convolutional layer is the most important layer of CNN, and it is also the origin and source of the name convolutional neural network. An algorithm is based on this convolutional layer. What kind of operations can convolutional layer do? The first one is the local association operation. That is to treat each neuron as a filter. And the second one is the window sliding operation. That is, filter is calculated on local data. Here in convolutional layer, there are few important nouns. The first one is the depth. The second one is the stride. And the third one is the padding value. Let's look at this chart. On this part, it is called the sliding operation window. Now let's look at the part on the right side. In right side, there are 5 neurons that constructed the convolutional layer, each of which represents the depth of the convolutional layer. In this picture, it is the depth of this layer is 5. And how to calculate in the convolutional layer? Now let's see the process of the calculation of the convolutional layer. First of all, the filter will slide all over the entire image to perform repeated dot product operations. That is dot product addition. In input layer, which is the green area in the chart on the right side, and it is called the convolution area of input image. We can call it area A. And then in the middle part, and this is a filter that is 3 multiplied 3 area. Next one, we can see a 0 here. And this is the result of the output after the calculation. Let's see how it calculates in this layer. The first one here, that is the data shown, and the first part, the green part. And the second part is the filter. Now we operate the dot product operations. That is to use this 1 and this -1 and multiply them, and use the 0 and the 0 in the filter to multiply, and then edit them. And in the result, it will be one of the data as the result, that is the 0. And this is the principle of operation in convolutional layer. Actually, in the green part, after the calculation, it will move the filter. Let's say if we set it as 1, we can move it on the right side to 1 column. Also, we can move it downside to 1 row. And according to the method of calculation, we can do the further calculation as well. And in result, we can get an output after the convolutional calculation. Now let's look at the next one, that is called the incentive layer. In neural network, the neuron needs to compare to the threshold to activate the neuron to transmit the information backward. Same in convolutional neural network. The activation process is also required after convolution. The function of incentive layer is to conduct non-linear mapping of output result of convolutional layer. And this is called the incentive, and this is the function of the incentive function. Let's say in the neural network, if we don't use the incentive function, the output for each layer is the linear connection and or function for the next layer. No matter how many layers are there in the neural network, the output is always a linear combination of the input. So in this situation, it cannot be simulated to the biological neural network. In this way, we have to add the incentive function to introduce neuron with nonlinear factors so that the network can be applied to many nonlinear models, so that the neural network can approximate any nonlinear function arbitrarily, and also the more powerful expression ability can be obtained. And this is the function in the incentive layer. Now, let's analyze the activation functions in the incentive layer. The first one, I will introduce the sigma function. This is a common S-type function. We can see the chart on the right side. This is a common S-type function. Also, it is called the sigma growth curve. In information science, due to model increase and inverse function model increase properties. The signal function is often used as threshold function of the neural network. That is, to map variables between 1 and 0, 0 and 1. And there are advantages and disadvantages of this function. First, advantages. The signal value range is between 0 to 1. It's relatively simple. And the disadvantages of it is that it prompts to saturation and termination of gradients transfer. That is called the dead neurons. And the function output is not zero-centered. And this is the disadvantage of this function. Now, let's look at the next activation function, which is called tanh. Tanh function is one of the hyperbolic functions. Tanh is the hyperbolic tangent function. In mathematics, the hyperbolic tangent tanh is derived from the basic hyperbolic functions. Those are hyperbolic sine and hyperbolic cosine. The advantage of this function is that the value range is between -1 to 1, which is easy to understand, and this function output is centered by 0. Also, it has the disadvantages, that is, to prompt to saturation and termination of gradient transfer, that is called the dead neuron. And the picture shows you the tanh function. Now let's look at the next one. ReLU. ReLU activation function is used for hidden layer neuron output. The advantages of it compared to above two functions, the conversion speed is improved, and the gradient solution formula is relatively simple. The gradient disappearance and gradient exclusion will not be caused. Also, it has the disadvantages that it has no boundary. Also, it is able to use the variant ReLU, which is the function main. However, this function is fragile, that it is easy to fall into dead neurons. This can be solved by a small learning rate. If you're interested, you can search for more knowledges in this area. Those are the basic functions in incentive layers. This one, let's look at the next layer in CNN, which is called the pooling layer. The pooling layer is in the middle of consecutive convolutional layers, and it is used to compress the amount of data and parameters to reduce overfittings, so that it is used to de-dimension. If the input is an image, then the main role of pooling layer is to compress the image. Let's shape this image here below. When the data goes through the pooling layer, it is compressed. And this is the function of pooling layer. Now the next one is called the fully connected layer. After multiple convolutions and pooling, the final pooling result is input to the fully connected neural network. And prediction result can be output at the end. Now, this is the content for the first part. Now, let's look at the second part. That is model evaluation metrics. Why are we going to evaluate the model? Because when we train the model, we need to know that in this model, during the producing of our life, does it work or not? And how to evaluate it? There are many indexes. Now, let's look at those indexes in this part. First of all, model evaluation is to evaluate the performance of the trained model. Model evaluation is an integral part of the model developing process. It helps to discover the best model for data expression and the performance for future work of selected model. Of course, we expect the model to be the best, and it will be greatly help us in our life. The common evaluation indicators for classification tasks are accuracy, precision, recall rate, F1 score, and ROC curve. Now I will introduce these indicators respectively and how to calculate it. Now let's look at the first one, that is accuracy. The accuracy rate is the proportion of correct classified sample number to the total sample number. Here the formula is shown for the accuracy rate calculation. In this formula, there are some abbreviations such as TP and TN. Those are the algebra. And let's see what it represents. Those TP and TN are extracted from the confusion matrix. The picture below is the confusion matrix. This matrix is to report the prediction result and the comparison between the result predicted to the actual sampling data. For example, TP here means the true positive. That is to say, we predict it to be positive, and it's actually positive. Here, FP, F means false, and P means positive. It represents that while predicting it is positive, but it's actually negative. And the next two are the same. Let's look at this formula. One above is TP plus TN. So TP means the true positive. The first one is that it predicted to be true, and it's actually true. So it is TP. And the next situation is that it is predicted to be negative, and the actual data is negative. And that means it predicted the right way. So the total number is TP plus TN. And those numbers below is the total sample number. That is TP plus TN and plus FB and plus FN. Through this formula, the accuracy rate is calculated. It is hard to remember of this formula. Actually, if you think about it deeply, it is not that hard to remember and comprehend. Now, let's look at the next index, which is called the precision ratio. Precision ratio refers to the proportion of the samples predicted to be positive by the model and that are actually positive to the samples predicted to be positive. Try to read it multiple so that you will get to know the meaning of this sentence. The precision refers to the proportion of the samples predicted to be positive by the model that are actually positive to the samples predicted to be positive. The formula here is to show you the precision precision ratio. And also, you have to have the basic concept of the confusion matrix. I would encourage you that you need to have the deep understanding in the confusion matrix, such as T, P, and FP, so that you will get to understand and comprehend the formula. Next one is the recall rate. What is called a recall rate? It refers to the proportion of actual positive samples that are predicted to be positive to the actual positive samples. Same here, you need to probably read it twice to understand the deep meaning of this sentence. Also, here is the formula for the recall rate calculation. After the calculation, the value of R is from 0 to 1. The larger the value, the better the effect. That is, more achieved to 1, and the model effect will be better. When you comprehend the formula, you need to combine to the confusion matrix so that it will help you better understand the formula. Now, let's look at the next one, which is called the F1 score. What is F1 score? It is the harmonic mean of precision rate and recall rate. Also, here is the formula for the F1 score calculation. In this formula, it has the precision and the recall, and to calculate the harmonic mean, and that's the function of F1 score. And in the result, the higher the F1 score, the more stable the model. Also, you have to first understand the precision and recall rate, and then compare to the confusion matrix so that you will understand the F1 score here. Now, let's look at the next indicators. Next one is called the PR curve. For this curve, by constructing multiple sets of precision rate and recall rate, and this PR curve of the model is drawn with the horizontal axis of recall and the vertical axis of precision. Here we can see the x-axis is the recall rate, and the y-axis is precision rate. And to construct multiple sets, and this curve is drawn so that we can call it PR curve. So the next part, that is the TensorFlow basics. During this part, I will talk about the basic concepts of TensorFlow and functions, so that after the training, you can spend some time to remember those functions and concepts. Over here, we take a 10 minutes break and we'll come back and continue our training. Now we'll take a 10 minutes break. After 10 minutes, we'll come back and continue our classes.
好的，那么我们呢继续往下来讲解。
Ladies and gentlemen, welcome back to the training. We'll continue our lecture. Now we will talk about the part 3, which is the TensorFlow basics. Let's see the common functions in TensorFlow. After the class, all the participants can do some research about the functions in TensorFlow and the ways of operations. First of all, the basic concepts of TensorFlow. In TensorFlow, there's one word which is called tensor. Tensor is the basic data structure of computational graphs. Here I mention another thing, that is computational graphs. Later I will introduce it. Computational graphs can be regarded as a multi-dimensional data. Flow here represents the process of mutual conversion between tensors through calculation. Basically, tensor is a physical quantity, and it is a tool for dimensional analysis of physical quantities with high dimensions. That is to say, the dimension is greater than or equals to 2. It can be simply regarded as one-dimensional array is called a vector. Two-dimensional array is called a second-order tensor. And three-dimensional array is a third-order tensor, etc. and etc. Now we will talk about flow. Whether it is the music or the other data. Here, music can be regarded as a kind of data. As long as it flows, flow here is an adjective. It can be regarded as flow. So the computational graph is a series of TensorFlow arranged into a direct cyclic graph. Let's look at that in TensorFlow, the common operations and functions we will use. Here, I will not show you the actual coding. I will just demonstrate it to you on the PowerPoint. The most important here is to remember those functions. Let's look at the first one. That is to convert string to numbers. Let's see. If you have a tensor that is in the format of string, we use this function to convert it to the numbers. Now here, TF, it indicates TensorFlow. And this is a way to name it. Commonly, we import TensorFlow, we usually rename it to TF. That is to say, in the IDE toolkit to write the code, if you directly type in tf.string to number, in this way, you cannot use this function. So first of all, you need to import TensorFlow. And the way of it is to type in import TensorFlow. In order to simply write the code, we can rename the TensorFlow to TF. And here, the TF means the TensorFlow we imported. You have to understand it. For saving time, I will not show you how to import it. When we write it, this is the part that you have to pay attention. You have to first import the TensorFlow to use these functions. This is the first one, that is simple. And let's look at the next one, tf.2-double. This function is to convert to 64-bit floating point type. That is, we usually call it the float 64. And if it can be converted to the float 64, we can also convert it to the float 32. Let's say if you need to convert it to a 32-bit floating point, we use tf.2 float. Also, some of the data, you need to convert it to an integer. For example, the integer 64, we can use tf.2-in64, this function. Here is the one that is commonly used. That is the tf.cast. This function can convert x or x values to d-type it. And this one is commonly used. I would encourage you to use these functions more to practice. Next one, let's look at the other functions. And this part is the shape manipulated. We use tf.shape here. It returns to the shape of the data. Next one, if we need to obtain the elements number, we use tf.size function to return the elements number of the data. And next one, to obtain the rank of the tensor, we can use tf.rank function to achieve it. And this is relatively simple as well. We can directly import it and operate the data and utilize this function, and it returns to the rank of the tensor. We can regard it as dimension. Next one, let's say if we try to change the shape of the tensor, we use this function, which is tf.reshape. This function supports changing of the shape of the tensor. Well, it is worth mentioning that this shape is imported by you yourself. Next one, that is to insert dimension 1 into a tensor. The function is tf.expand-dims. It is pretty hard to comprehend this function. You ought to do more practice with these functions. It is actually increase the dimension of the tensor. Let's say if you need to operate this way, you can use this function to achieve it. Now, let's look at some other functions. Next one is slicing and merging of the tensor operations. These functions are relatively simple. Here I listed just for you to know some basic functions. And in the daily life, you can utilize some of these functions. Because importing functions is relatively simple, so here I will not demonstrate it for you. The first one is to operate slicing on tensor. And the next one is to split tensor into non-dash split tensors along a certain dimension. We can use the function of cf.split to split the tensors into certain numbers. Next one, we can also use tf.concat function. And this function is to connect tensors along a certain dimension. So when we connect tensors, we can use this function. And this one is commonly used as well. The next one is tf.pack function. This function is to pack a series of rank-r tensors into a rank-r plus 1 tensor. Here, it refers to dimensions, which is called the dimensions of the tensors. Now it goes to the next one, which is tf.reverse function. This function is to reverse the sequence along a certain dimension. If you need to reverse a tensor, you can use this function. Now, let's look at the next one, which is tf.transpose function. This function is to transpose tensor's dimension order and the transpose tensor sequence according to the dimension order of the least term. Next one is also the one that is commonly used, that is tf.1-hot. If you have learned the relative cost, you have already used it. And this function is to convert input to data output of one hot type. And this is very important. Here, while we're calculating the CNN, we have already mentioned it. And I have introduced the advantages of the one-hot code. It is mainly to solve the problems, the algorithm. Now let's look at the next one. And this part is about the matrix operations. Let's look at the first function. cf.diag function returns to diagonal tensor with given diagonal value. So we can set the diagonal value and returns a tensor. And it is also relatively common used. After class, you can try it. And the next one, tf.transpose. That is to transpose the dimension order of tensor. I have already mentioned it. So the next one, tf.mapmove. And this one is the matrix multiplication. While we do the matrix recurrent, we will use this function. And next one, this is function to return the determinant of a square matrix. And the last one, this function is to find the inverse matrix of the square matrix. So in this function, there's one parameter. Here the parameter adjoint equals to none. If you set it to none, it will calculate the reverse matrix of the data. Now let's look at the next one. That is the common used activation functions in TensorFlow. You need to use corresponding activation functions. How can you import it? Now, before, I have introduced several activation functions and also the advantages and disadvantages of it. If you remember all of those advantages and disadvantages, when you use the activation functions, you will know which function adapts to the certain operations. So first one, if you use the sigma function, that is to compress the output to the range of 0 to 1, as I mentioned before. Now we go to the next one, that is the tanch function. And this one is common use too. This function is to compress the value between -1 to 1. And also here, value function, it increases the input value that is less than 0 to 0. And if the data you input is greater than 0, the function will keep the input value, and that's the function of this one. And next one, softmax function. This activation function is to normalize an n multiply 1 vector to a value between 0 to 1 to make the features of larger values in a vector more obvious. And this function is also commonly used. Next one, that is soft plus. Here, let's take a look at this. This is the formula of this function. Now let's look at the next one, that is the dropout function. This function is to randomly drop some of the neurons during the training process. So in this training process, the weights are not updated, nor participate in the calculation process of the neural network. And that is the characteristic of this function. It is worth notice that the position of these activation functions. Let's check all of these functions. We directly use TF to import it. And those are the common use activation functions of TensorFlow. Now let's look at the next part. That is to use TensorFlow to process image. And those are how to utilize TensorFlow to process image. The first one, image random resizing. Now here the function is shown on the screen. That is tf.image.resize -width -crop -or -pad. And the next one, that is to crop tensors to a random given size. We have to understand that the size is given by you. Next one, that is image rotation of 90 degrees on a counterclockwise. The function is tf.image.rot90. And this one is commonly used because while processing the images. Those operations are usually used. And also the last one, that is adjust the contrast of the image through a random factor. And the function is shown on the screen. In this part, I will introduce the model construction by TensorFlow. While constructing model, we import Keras models. And the type is sequential. In this way, we need to import the network structure. For example, the fully connected layer and the convolutional layer. No matter what kind of structures we import, it helps us construct it. So we can directly use Keras. And this one is relatively simple. Let's look at the next part. After the model is trained, we need to save the model. So it is easy to save the model. We can use a method. Saving model is for everyone to master it. That is to say, finally, you need to save the model you trained through the process. Let's take a look at the methods of the model saving. The first one, we can use save methods to save both structures and parameters of the model. Here we can change the name of the model. Here we name it model.h5. In this way, the model saved. If we try to load it, how can we operate it? Through Keras, we can import the load-model method. In this way, we can load the mode that we saved. In this way, we need to define the name and path of the mode. After sending in, it is able to load and use it. Except this way, we have another way to load the structures and the models. The previous one is the structures and parameters. It saves all together. Let's say if we try to save the model, parameters, and structures separately, we need to use such methods as below. Firstly, save the model. We use this object, model save weights, to save the structure of the model. Also, we need to name this model. In this way, the parameter of the models are saved. After the parameters are saved, we also need to save the structure of the model. Here, we can use this way, showing on the screen. In this way, we can save the structure of the model. So let's look at the parameters and structures of the models when they are saved. If we try to use it, how can we operate it? Since it is saved separately. Because we have to use the model, both the parameters and structures. These are separatable, unseparatable. Here I will show you how to use it. First, it is saved as two files. We will need to use them separately. First of all, through the caret, we import the function that is model import, that is model from JSON. By using this function, we use the model. First of all, the object model has a load weight method. That is to load the saved parameter. After loading, we can use this parameter to combine the models and operate it as we import the previous one, that is the model from JSON. By using this method, we can load the model saved before and its structure as well. Now we will go to the next part, the part 4. That is the introduction to common models. In this part, it is worth mentioning that during the competition, it doesn't mean that all of these models will be used in the competition. And here we will not do the further and deep instruction of these models. After the training, I encourage participants to do the self-learning regarding to these models and occasions of this model utilizing. First of all, let's look at the first one. It is called the LeNet 5. It is a CV classic model. This model is classic. It is a classic CNN model. And it is also the origin of the CNN. That is to say, there are various of the models and algorithms that refers to this model. While this model is invented, it is used for the posting code recognition. It has the ability to recognize and learning. And LeNet is also called the LeNet 5. It has one input layer, two convolution layers, and two subsampling layers, and three full connection layers, as it is shown in this image. You can see there are three full connection layers at last. The last full connection layer is the output layer. Here, you will need to have a full picture of this model. And this is how the layers are laid in this model. Now let's look at the next model, which is called the AlexNet. This AlexNet model is also famous in the deep learning frame field and is usually used a lot in this field. Here in AlexNet, there are 8 layers in this model. There are 5 convolutional layers, 3 full connected layers. In each of the convolutional layer, there's one ReLU activation function. That is to say, this is the structure of the AlexNet, and that is the basic structure of this model. Now let's look at the next model, which is called the VGG net. We can see from this picture that it seems a little bit complicated. It's VGG 16 comparing to the AlexNet that it adopts continuous 3 multiply 3 convolution instead of the larger convolution pairs in AlexNet. To the given data, it is related to the output to the data, which is related to the input data. We use the small convolutional pair, which is better using than the larger convolutional pair, because in the multi-layer, it increases and supports the way of the model learning, and the cost is less because the parameter is less. And this is the instruction of VGGNet. Now let's look at the next one, which is also famous. And it is called the deep residue net. This model is also called the ResNet. In 2016, Microsoft company and the laboratory in the Microsoft company invented, and it occupies, and in the competition in 2015, it obtains the first prize in the competition, and it is a good result of this model. And it is also got the first prize of the image segmentation competition. So it has a great history of this model. For the traditional convolutional neural network, that is to through the upper line layer and convolutional layer and accumulate them to a certain depth of the internet, of the network. In this way, 2 problems occurs. The one is diagram descent and diagram explosion. In ResNet assay, through the pre-processing of the data and the coding in the network, it helps solve the problem of gradient disappearing and gradient explosion. However, it is not totally solved. So in general, this model is in a great progress, and it is commonly used as well. After the training, you can try and search for some data files to learn this model. Next one, I will introduce another classic model, that is inception model. In CNN, from Alex Knight, the way of its breakthrough is to increase the depth of the internet and the width of the internet and reduce the parameter and reduce the amount of calculation. However, the level up of the depth will cause the increasing of the parameter, and that will cause overfitting. In another aspect, the deeper the network is, the gradients, the more backward the gradients, so that it is more easy to disappear. And that is called the gradient dilution. In this inception model is invented on this situation. Now let's analyze the advantages of this model. Here, we use the 1 multiply 1 convolutional neurons with high efficiency. It uses the very less calculation to increase the features of the layers, including the linear features and linear fictions. Also, it appeals one of the BN layer through some methods. It changes the value of the neuron to each layer and pull it to the value of 0, so that it drops into the sensitive neuron areas to reduce the gradient disappear. And also, it imports the inspection model and 4 branches altogether. Each branch will use 1 multiply 1 convolution to reduce the full connection layer and change it to an average holding layer. In this way, it reduces the amount of calculation in a large extent. Now, let's look at this picture. In inception, there's V1, V2, V3, and V4, etc., and etc. Let's look at the first one and check the differences between these models. Now let's look at the inception V1. This one, it reduces the full connection layer. Instead of it, we use the average polling layer instead of it. It mainly changes and creates the 1 multiply 1 convolution layer. In this way, you reduce the thickness of the feature image. And this is the structure of the inception V1 model. Now, let's look at the inception V2 model. In inception V2, it adds the VN layer. Through some methods to change the input value of each neural network to an average parameter to avoid the gradient disappearance. Next one, it learns the structure of the G using 3 multiply 3 convolutional neurons instead of 5 multiply 5 convolutional neuron. In this way, it reduces the amount of parameters and speeds up the operation. In this way, while reducing the amount of parameters, it actually increases the nonlinear calculation. And the structure is simple. And it is more wide. Now let's take a look at the Inception V3 model. In Inception V3 model, it has a very important refining. It separates 7 multiply 7 to 2 simple convolution. Here, 3 multiply 3 segmented to 1 multiply 3 and 3 multiply 1. By doing this, the advantage of it is that it helps increase the speed of calculation. What's more, it helps change the 1 convolutional layer to 2 so that it increases the depth of the network as well as increasing the nonlinear parameters. And this is the difference between Inception V3, V2, and V1. Well, actually, Inception model has the V4 here. I will not introduce the V4 model. If you're interested, you can search for some files to see on which side V4 is refined. So those models are commonly used, and there are actually a lot of those models. And this requires more time amount for the participant to learn. Those are all the content for today's training. Now, I will give you some time to see that if you have any questions, you can present it now. And if you don't have any further questions, we will end today's training.
Hello.
Now it is the time for Q&A session.
Hello.
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 Felix Sam, go ahead and ask the questions.
Okay. Good afternoon from Ghana. First of all, I want to give every participant good afternoon from Ghana, wherever they are listening. It's afternoon here now. So my question is pertaining to the models. When he started, he said, we are not going to use all the models, but during the competition. So I want to ask whether maybe the question will be specific in which model to use, or you have to choose between the models you want to use.
Okay.
我先来说一下第一个问题啊，对同一组数据啊使用，我看一下， 第一个问题啊，这个 TensorFlow 怎么旋转指定的角度？这个呢也是非常简单的，调用一个函数就可以了啊，调用一个函数就可以了。
Hello, the participants from Ghana, can you hear me?
Yeah, I can hear you.
There are some technical problems. There are some technical problems in the Zoom. We are now adjusting it. Please give us a second. Thank you very much, because the lecturer didn't hear me, and we will try to adjust it.
Oh, okay, I'll be waiting.
它可能会适合什么样的这个模型比如说咱们的这个模型它最终呢可能是用来做这个分类是吧回归等等这样一些任务的那么有的模型呢它可能对这个分类这个是有更好的效果有的模型呢它可能对这个回归可能是有更好的效果所以呢我们在选择的时候第一个通过这个凭这个经验另外一个还有呢就是通过这个算法的一些特点语音和文字识别考试会涉及吗？文字识别这个的话呢会严格的按照咱们这个发布的那个考试标准那个来会严格按照那个来所以呢大家去看一下那个标准就可以了题目的任务类别是否有具体范围咱们这个题目主要呢是围绕着这个视觉这一块视觉这一块也就是只要属于计算机视觉这一块的呢都可能会涉及再来我们来看一下这个本次培训中我们看一下咱们这个加纳选手问的本次培训中并不是所有的模型都会在大赛当中被使用是否能够具体说明哪些模型会被用于竞赛中谢谢好那么这个呢我们是不能说的也就是在这里呢是
To your question, the specific models used in the competition will not be told.
好吧那么赛前的话呢如果说这个试题会公布的话大家呢去看一下咱们这个试题基本上你能够清楚到时候
Please follow up with the official announcement so that you will know the specific information of this competition.
分割检测的都有可能吗分类肯定有可能是吧
Mr. Felix M.
分割
I'm listening.
Okay, that is the answer to your question.
不过可能这个分类还有这个检测这两块呢
Okay.
要多一点好接下来我们看一下说请问一下参赛选手的群号是多少群号这个的话呢我不是很清楚因为我是上课的那么这个的话呢明天在这个上课的时候可以问一下那个舒老师这个具体的群号这个呢我也不清楚好接下来看一下还有没有这个竞赛规程是能否发布这个的话要看咱们这个组委会要问咱们组委会这边好吧我这边的话呢大家呢还是多问一些我培训的内容可能会多了解一点 考试内容是否局限于所讲内容这个不是不是刚刚我们说了，它可能就是会涉及到咱们这个计算机视觉这一块当中的很多内容很多内容，比如说它不会。
For your information to all of the participants, the content in competition will not be limited to the content of the training. In the training session, those are the important part and the basic part. In the competition, it includes more knowledges and models.
咱们这个 ROC 曲线的话呢，你说它的值需要函数还是可以使用这个 scikit-learn 用 API 那么这个一般情况下呢，是可以调用相关 API 的可以调用相关 API 的但是这里要注意可能不是使用 scikit-learn 是吧？也就是说不一定不一定是使用 scikit-learn。请问比赛中有这个 scikit-learn 库吗？那么这个的话呢是要看咱们那个规程了它上面会有所有我们要使用的这个库还要使用的这个库以及这个环境它都会给你这个介绍。那么上面有的呢你就可以用，上面没有的呢你就没办法用好吧？以前的规程有是吧？但是前天的没有那么肯定是要按照最新的了最新的这个规程不用谢不用谢。还有这个问题吗？我看到还有一个是吧？池化的下采样和上采样各自的特点是什么？上采样那么上采样一般情况下呢，我们呢是它的目的主要呢是用来做这个放大原图像放大原图像从而呢可以使这个显示在这个更高这样一个分辨率的这种显示设备当中对图像的缩放操作并不能带来更多的这个关于这个图像的信息那么也就是说这个图像的这个质量可能会受到影响然后看一下这个下采样，下采样它主要呢是使得这个图像符合显示区域的一个大小，然后呢可以生成对应的这个图像的缩略图区别不大，区别不大。 比如说这个上采样，它这个图像放大，它基本上呢都是采用这个内插值的这样一种方式啊。比如说有这个双线性差值是吧？反卷积反实化这样一些这个方法啊。好的那么没有问题的话呢咱们今天的课程呢就到这里啊。
Okay, if there's no more questions,
谢谢大家谢谢大家。
the training for today is now end. Thank you very much for your participation.
咱们课程呢就结束了呗？结束了啊。
Now
明天
we will end today's training,
再见各位。
and I will see you tomorrow.